Hi guys, alright, this is Unit 2, Day 2. These nodes we'll be using today and in Day 3, okay? So we're only going to do a few of these for today. So the first part is to express the volume of a cylinder in terms of its height if the radius is half as long as its height. Alright, this is similar to yesterday's notes. The problem that was like, express the circumference of a circle in terms of its area, right? So this is the same thing. I told you guys to stop and write the equation down before you hit the word in terms of, okay? So in this one, we're going to find the volume. So I'm going to write down the equation for volume. And then it says in terms of its height. That means I only want h in that volume equation. So we definitely have to get rid of the radius. But then it tells me a lot of this junk about this radius is half as long as its height. Okay, so let's actually translate this last part. Radius is r equals half as long as its height. So half the height. Or I can just say h over 2. Same thing. For me, the second one's actually easier when I have to plug it back in. So we know what the new r is in terms of h. I'm going to take that value and I'm going to put it into the r into the volume equation. So h over 2. H, don't forget the squared. Cleaning it up a little bit. This is h squared over 4. Do not forget to take the squared of the bottom, okay? This is that last h. And then I'm just going to combine some like terms, like those h's. I'm going to clean those guys up. So I'm going to get h cubed. Remember, add the exponents all over 4. That's my final answer. Alright, example 2. Given this function, we have to find a couple things. First off, does the function have a minimum or a maximum value? Hopefully at this point you're already answering that it has a minimum. You should also be saying why I have a minimum. The reason why is because it opens up. I know that it opens up because the a value, aka in this function, is the 1/2, is positive. If a is positive, you are opening upwards. For b, what input gives that value? So I am asking you, what is the x value of the vertex, okay? Input are x's, right? Outputs are our y's. So absolutely, you can just graph that guy and find the minimum. By hand, understand, it's like the axis of symmetry part, right? The opposite of b over 2a. So in this problem, that's a -6. 2 times half. Positive 6 on the top. 2 times half is just 1. So this does equal just a positive 6. Okay? So when I ask for the input, I want the x value. What is the min or max value? Now you're going to use your x coordinate to find the y. Or if you already graphed it, you already know what the y is, okay? But if you did go by hand, I would just be plugging in my input into the given function to see what my output is. So if I solved it algebraically, checked it with my calculator, you should be getting a -16. Okay, so I'm going to write that as a coordinate. And that's it. So I'm just here making sure you understand when do you have a min and a max, and understanding you know what an input and the max value or min value stand for. Example 3. A manufacturer of lighting fixtures has a daily production cost of that equation, where C is the total cost in dollars and X is the number of units produced. Use your calculator to determine how many fixtures should be produced each day to yield a minimum cost. I'm already telling you that you should be having a minimum when you graph this, okay? So step 1 is I would plug this into my calculator, right? So plug in calc. So in Y1, you should be plugging this into your calculator as I speak. Step 2 is going to be hitting the second trace button and hitting the minimum, okay? Then go to the left bound, go to the right bound. If you cannot see it, it's because you have to mess around with your window. I noticed that this has a y-intercept of 800, so I definitely need to change my scales. Here's my hint. If you are not good at changing your windows, okay, if you hit zoom, I believe it is 0 now. That's the zoom fit. That automatically makes your screen go straight into just showing where the min and max is. It's going to be super blown in, but that will always have your min and max in there, and then you can find it that way. If you are messing around with your window, my hint to you is for my X minimum, I would have put 0. My X maximum, I would have put 30. My X scale would have been 2. My Y minimum would have been 0. Y max, I would go a little bit over 800, so like 850. And then my scale would probably go by 50s, just because I need to get up to that 850. So each tick mark on the y-axis go by 50s. All right, when I find it, you should be getting 2700. What am I asking you though? I am asking you how many fixtures should be produced. I am asking for the X value. Want the X. So there is going to be 20 fixtures, right? Word problems need word sentences as answers. So 20 fixtures should be produced each day to yield a minimum cost. All right. If you were like wondering like how did she know what to write, like what's the proper wording or whatever, guys, here's a little hint. I literally just copied the question, except instead of the word how many fixtures, I said 20 fixtures, and then I literally copied exactly the rest. Should be produced each day to yield a minimum cost. Do the same thing, okay? Don't be thinking of a nice wordy stuff. Literally copy my sentence or my question, just replacing the how many with the answer, okay? All right. Let's go in to example 4 then. The height, y, in feet of a ball thrown by a child is given by that equation, where x is the horizontal distance in feet and where the ball is thrown. All right, so how high is the ball when it leaves the child's hand? I'm looking for height. I'm looking at 0 distance. Okay, so when it leaves the child's hand, that is the starting point. That is now a horizontal distance of 0. That means when x is equal to 0, right? So if I plug in 0, I know it's going to wipe out the -half or the -1/12 and the 2, and you are just left with the 4 at the end. That always exists, guys, because I'm asking for the y-intercept. So it is going to be, right? I'm asking how high is the ball? It's 4 feet. So this question is asking, maybe you want to write a little note to yourself. It's asking for the y-intercept, the y value. What is the maximum height of the ball? Well then, what am I asking for? Hopefully you are going to plug this in to your calculator, and what I want is the y value of the vertex. I want to know what's the highest point, right? So plugging this in, or you can go by hand. I'm totally fine either way. Just be careful of what directions I tell you. If I tell you by hand, make sure you go by hand by using the x equals opposite of b over 2a, figuring out that x value, which should be 12, just saying, and then plugging that 12 back into the equation, okay? So hopefully at this point you have already graphed it and you have the vertex, and I got it to be 16. I'm making sure I'm putting my units on these guys, so please, please, please make sure you put units. Okay? And see, how far from the child does the ball strike the ground? So what am I asking you here? If it's striking the ground, its height has to be 0 again. So I want to know at this point, what is the x-intercept, right? When does it hit back down? So please, please, please go in there, find your zeros. So hit calc 0, and you should be getting one. I'm going to approximate this one. I got this one as a decimal, but I got it to be about 26 feet. All right, so make sure when you graph that you get the same thing. So example 4, there was no really like math involved in these, right? This was straight up using your calculator and just dissecting what is the information that I need to grab from my calculator, okay? So if I'm asking from like example A, how high is the ball when it leaves the hand? Well, that's the y-intercept. What's the maximum height? Well, that's my vertex, the y value, right? If I asked how far do I go for the maximum height, well then that would have been like the x value from the vertex, right? How far from the child does the ball strike the ground again? That's my x-intercept, right? So this one just is telling you, I'm trying to figure out, no math involved, it's just do you understand what I'm asking you and pretty much what I'm asking you to find and where to go to find it, okay? All right. And then we have example 5. All right, we need to find two numbers whose sum is 23 and whose product is a maximum. Does your answer change if the numbers have to be integers? So I'm going to dissect this again. Find two numbers whose sum is 23. I'm going to pause. That's an equation right there. So I'm going to label this as my first equation. Sum. So adding two numbers, I have no idea what they are. So don't be giving them values. Do not be saying 1 plus 2, right, or whatever, or actually like 22 plus 1, right? We don't know what they are. So two random variables. When I add them, they're to 23. Also, at the same time, their product, those same two numbers are going to give me a maximum. So my second part from here is not really an equation because they didn't say their product is something, right? They're just saying when I have their product, it's going to be maximized. All right, so my step 1 is I need to manipulate one of these expressions / equations, and I need to plug it into the other one. Okay, so when I look at these two, I'm having an issue manipulating one of these. Hopefully you are saying that the second one I cannot manipulate because there is no, like it's not an equation. There is no equal sign, so you can't move anything to the left or the right with inverse operations. So that leaves me with the first equation. If I need to graph this into my calculator, right, to figure out the max, I'm thinking I should isolate the y because that's the only way your graphing calculator knows how to graph. All right, so I'm going to take the first equation. I'm going to get y by itself, so I'm just going to subtract the x over, and I get y equals 23 minus x. Okay, so now that I have a y, I can actually plug this guy in for the y, the second one, right? Because I have to combine them two together. So when I do that, I'm plugging in now. This was the original. I'm just going to write it as x times y. Now x, the new y, which is 23 minus x, plugged it in. I'm just going to distribute that x in. So 23x minus x squared. Great. I know for a fact this is a quadratic, right? Because it's squared. I know I'm going to have a max because it starts off with the negative x squared term. So type this into your calculator and you're going to find out the max. Again, I tend to just use zoom 0. I'm going to write that down. You should be working in your calculator now. So zoom 0, that's the fit one. That will always have your max and min in there. You could play around with the zoom in and out or your windows. I was just like a person that would go into zoom out. If I don't see it, then I go zoom fit right away. Okay. All right. Once you find your vertex, right, you should have done the left bound, right bound. I got it to be 11.5 and 11.5. So some people are like, wait a minute, that doesn't make sense. Okay, I'm going to rewind a little bit here. If you got 11.5 and 132.25, you did everything correct. Okay? But we have to understand, what does this mean? This doesn't mean the y number, guys, okay? This means that is actually the product of two numbers. So that is why I just took the 11.5. I took both of those, right, and just repeated it. So when I have 11.5 and 11.5, those two numbers get me to 23, and they have the biggest maximized product, which is 132.25. So the second question said, does your answer change if the number have to be integers? Well, yeah, because 11.5 is not. So if I have to change them, so if the numbers must be integers, I'm going to say 12 and 11 then. Okay. If they do not, then I'm just going to say that it's the 11.5 and the 11.5. All right, we're going to stop here. So day 3 is going to go from 6, 7, 8, and 9, okay? Make sure you tackle these guys out because you definitely want to have a nice foundation before we hit day 3, these other problems. Glance at the other problems, kind of see the type of way I'm asking you to find the questions. We're definitely diving in deeper into day 3, so I definitely want you guys to have a strong foundation going into day 3, okay? Make sure you keep advocating for yourself. Make sure that you're asking those questions, the why questions. Keep challenging me with these questions. I really would appreciate it. It's definitely going to help you out in the long run. All right, keep up the great work, guys.